All right, so last day we looked at these things called rates and unit rates and best buys. Basically, you're figuring out amount for one. And the way you did that is by dividing two numbers together. So depending on the question, you have two different kind of numbers. Most of the questions involved money. If the question involved money, the money number always goes on the top, and whatever else you have goes on the bottom. All right? Do you need one right there? Right? If the question involved time, those are the two main things. Time always went on the bottom. All right? All right, now, if a question didn't talk about money or time, and you're trying to figure out which way do you divide your two numbers, they'll give you a clue in the question, right? In the question, they'll say something like per kilometer. That means per means divide by the kilometer number. Or they may say in each bus, divide by number of buses, or something like that, right? So they'll give you the clue in the question if it doesn't talk about money or time. All right? Now, so when you divide these two numbers, sometimes you get a whole number, lots of times you get a decimal, right? So here was the fuel economy for my SUV when I'm driving around the city. That's not highway driving, that's city driving. Fuel economy for me. Look how small this number is, right? Often, when we do these calculations and you're trying to find the cost of one thing, that cost is a really, really small number. And your calculator may give you something weird on your screen. So when you get into grade 10 and 11, right, they're going to show you a different kind of number, how a number is written, right? And you don't really talk about in middle school math because it doesn't really show up with those kind of numbers, but except for in this chapter here, depending on the calculator you have. So now, when you get into science classes, and you end up talking about really big numbers, so you have a lot of zeros, right? There's no point of having all these extra zeros on your calculator screen. It just takes up space, right? So if something's really big can have a lot of zeros. If something's really small can have a lot of zeros in it. So your calculator gives this condensed version of a number. So some of your calculators wouldn't say 0.078. It would say something like 7.8 e negative 2. Or it may say 7.8 times 10 to the negative 2, or something like this, right? So this is called scientific notation. It's used for really, really big numbers, really, really small numbers. If your calculator, when you're doing this lesson and you end up with something small and you end up with something like this on your calculator, the only thing you really need to know is this little negative 2 that they give you, or maybe it's a negative 3 they tell you. It tells you how many spots to move the decimal to get to the real number. So this means move the decimal 2 spots this way. So this number is actually like this, 1.2.078. That's what that means, okay? So when you get to grade 10, they'll go into more detail, but a couple of your questions, depending on the type of calculator you have, your calculator may spit out a number that looks like that. Or, for example, it might be 5.6 times 10 to the negative 3. That just means move the decimal 3 spots. You go 1, 2, 3, drop the decimal there, and just fill in with zeros. So 0, 5, 6. That's all that means, okay? So some of you guys will have that issue, other people won't. Just depends on the calculator you have, okay? All right, so this is our last question for this lesson, and we'll work on our assignment. It's an okay question. I thought about pulling it off the page. Math 8. many, many years, and the very first time I did this question, a student of mine was so confident that they knew the answer to what the best deal is they bet their shoes to me. I want a pair of Nikes off of this question. And I had this Nike sitting on the top of my thing all year long. Because the student goes, I know which one's the best deal. And then we did the calculation, and unfortunately the student was wrong. Luckily the student only lived across the street, so it wasn't that far for the student to walk.
I'll bet last year.
Mm-hmm. All right, so we have 3 cartons of orange juice here. The question is, which one's the best deal? All right, so we did questions like this. This is slightly harder than the ones we did on last class. Right? So what we need to know is the cost, and it's not given to you in the paragraph here, it's given to you on the diagram. So we have the 3 costs here. We have the small, we have the medium, and we have the large here. All right, and we need to know how much orange juice is in each one too. And that's written right here on the diagram. All right, so we just need to figure out what is the cost for 1 milliliter of orange juice. So we're just going to do it. So we have our small. Let's do our small one here. All right. So you have $1.69. When we write a fraction, does the $1.69 go on the top or does it go on the bottom?
On the top.
Top. Money is always on the top. All right. And you put the volume on the bottom like this. All right. And we divide those 2 numbers. So Mr. Dhaliwal, grab his calculator so you don't have to, but you can if you want. Here we go. And we go $1.69 divided by 414. And we're going to get something really, really tiny and small. Right? So this is the price per, oops, where did it go? This is the price per milliliter. Such a small number. We'll do that trick of timesing by 100 so it becomes a little bit nicer number. Okay? So I'll write this down, 0.004 something. All right? Then I'm going to just go times 100. So we get a little bit nicer number. So I'm going to go times 100. So dollar times 100. And so we can say it's, with money, we don't want to stop at 2 decimal places. So we'll say that's not 40 cents, but 41 cents. Okay? Because that 8 can tell us to round up. So we'll say this is 41 cents, not per milliliters, but since we times by 100, for each 100 milliliters, it costs you 41 cents. So remember, you have the option of timesing by 100 if the things get really small. So then you get the medium one. You got $2.99 divided by 946. And go times 100. So I'm just going to write it like this and go grab my calculator and go 2.99 divided by 946. I get that decimal. I times it by 100. All right. And
Can we just times it by 100 and
yeah, you can do it right off, but just show that you times it by 100 so I know that you did that. What number do we write down?
what?
What number do we write down?
Did we?
No, for this question. There's the answer.
Oh, dot 3.
It's money, so you want 2 decimal places. Right, Joe?
31 cents.
Not 31 cents. We stop here at 31 cents. Then we look at the next number to see if we stay at the 1 or round up. So we go up to 32 cents. So this is 32 cents for every 100 milliliters. Then we're going to go on to the large. So what number do we put on the top? What number do we put on the bottom?
$5.49 at the top.
Thank you. And what do we put on the bottom?
1,089.
Ooh, thank you. Close. All right, so now, whose voice was that? Kai? All right, so now, Kai, notice that, hey, the first one here said milliliters. this one said milliliters, but this one says liters. If we're trying to compare things, they all have to be out of the same amount, right? Else it's hard to compare. Like I said, the bag of chips. How do you compare 4 bags to 5 bags? By comparing 2 different things. So Kai says that, okay, we need to convert this to milliliters. So you need to be careful of this trick. If they're not all the same, you need to convert it to milliliters. And the one thing that you need to know, there is 1,000 milliliters in every 1 liter. So this 1.89, if I grab my calculator and I times it by 1,000, that tells us how many milliliters this is. This is 1,890 milliliters, right? 1,890 milliliters. That's the number we want to divide by. That's what makes this one harder than the other ones on the other page. So on the assignment or on a test, at most I'd give you one tricky question like this. I wouldn't do too many of those, but I just want to say, are you paying attention? Do you notice that one of them doesn't match up to the other one? And just convert it, right? Okay, so I'll grab my calculator here and I go, I divide these two, so 549 divided by 1,890. You get this decimal, and I'm going to times it by 100. I'll write down my times 100 here. And, oops, I lost the screen. And it's, what number do we write down? 2 decimal places? Yeah, Timmy?
0.29.
0.29. No rounding this time. All right? Per 100 milliliters.
So you want to pair sneakers because of that little liter thing?
Yeah. So now, I converted this one to milliliters. We could have done the other thing. We converted all these other ones to liters if we wanted to. As long as they're all matching. Right? I'd rather just change one number than 2 numbers. So I just did the one thing. Right? Okay, so now looking at all 3. Which one's the best deal? Yeah. The large OJ is the best deal. Yes, Peyton?
Are we done?
We are done the notes now.